The first polio vaccine was invented by American physician Jonas Salk in early 1950s. Salk wanted this to reach as many people as possible, which is why he thought of using air balloons for awareness. Now, the balloon was in the form of a right circular cone surmounted by a hemisphere, having a diameter equal to the height of the cone. These balloons had to be inflated by a pump. The amount of gas to be filled in the balloons will be equal to the volume of the balloon. To find the volume of the balloon, we need to consider its shape and size. Total volume of the balloon will be equal to volume of cone plus volume of hemisphere. But the challenge was to accommodate balloons of varying sizes, which implied a requirement of balloons of different heights. Consequently, they needed to establish a mathematical relationship that could help them to understand how the volume of balloon would change in relation to its height. And whenever we need to find out the varying rate of change of a function with respect to an independent variable, we should apply the concept of derivatives. And here exactly we need to find out the rate of change of volume with respect to the change in the height of the balloon. So let's understand the mathematical solution. If h denote the height and r denote the radius of the cone, let v denote the volume and h denote the height of the balloon. Here we have to find out derivative of v with respect to small h, that is dv dh. The total volume of the balloon is equal to volume of cone plus volume of hemisphere. V is equal to 1 upon 3 pi r square h plus 2 upon 3 pi r cube. Since it is a condition that diameter of the cone is equal to height of the cone for every balloon, that means 2r is equal to capital H. Now as it is clear from the figure that small h is equal to r plus capital H, we can write 2r in place of h because it is given that height of the balloon is equal to diameter. So total would be 3r. Now because we want to develop the relationship between v and h, so in place of r, we would be putting the value of r in terms of h. So in equation 1, we will be putting r is equal to h upon 3. On solving, we got the value of v in terms of h. And now because they wanted to know the rate of change in volume with respect to height, so they differentiated both sides with respect to h. In this equation, they simply had to put the value of h to know the rate of change of volume with respect to h. For example, at height h is equal to 3, the rate of change of volume with respect to height would be 4 pi upon 3 centimeter square. By simple application of derivative, they came to know about the requirement of gas which was supposed to be filled in the balloons. And did you know, Jonas Salk chose to not patent the vaccine or seek any kind of profit from it in order to maximize its global distribution. Isn't that amazing? I hope you liked the video. Thanks for watching.